Alright, in this short little video, I'm going to do a couple of sample problems. Not really doing so much new content this week, so we're just going to make sure that we kind of understand last week's content. There's a little bit of new content this week, but not much. So this corresponds to last week's practice, a couple of sample problems from the special right triangles practice worksheet. I'm going to take a look at number 6 and number 8. All right, so first, quick reminder. I can probably get away with it just putting it right here. From the theorem, the 30, 60, 90. X root 3 is the side between 30 and 90. X is the side between 60 and 90 degrees, and 2x is the hypotenuse between 30 degrees and 60 degrees. All right, so 9 over r, first fraction from the problem. Second fraction, corresponding side lengths from the theorem. 9 is between 30 and 90. That matches up to x root 3. R is between 60 degrees and 90 degrees. That matches up to x. The x's factor out. Cross product 1 times 9 is 9. R times root 3 is r root 3. And then to get r by itself, we're going to divide both sides by the square root of 3. R equals 9 divided by root 3. Okay, this is the right quantity, but it's not simplified. We need to multiply by the radical denominator over itself. This gives us 9 root 3 over root 3 times root 3 is the whole number 3. And then lastly, we can cancel the whole number 3 out of the denominator, and 9r is 3 times root 3. Once you know the short side, you can just multiply. The theorem says the hypotenuse is 2 times the short side. We just figured out the short side, so the hypotenuse has to be 2 times that number. Oops, 2 times 3 root 3. So that's 6 root 3. Right, so those are the two answers for W and R. 3 root 3 for R, 6 root 3 for W. For number 8, this one's actually even easier. W and 10. 10 is the hypotenuse, corresponds to 2x. W is the side between 60 and 90, corresponds to x. The x's factor out. Take the cross product. 2 times W equals 10 times 1, divide by 2. Once you know the W value, we can actually get the R value by taking W, 5, and multiplying by root 3. Because R is the side between 90 and 30, that's x times root 3, and W is my x value. So those are the two answers for number 8. I'm posting all of the answers, but just a quick little rundown of some of the work if you had some issues. All right, for problem number 1 from worksheet 7.5, this matches up to a lot of the 7.6 worksheets too. They just ask for the trig function. So at angle A, this is the opposite side, opposite across from A, and this is the adjacent side to angle A. And tangent in general is opposite over adjacent. So that's literally all we have to do. Tangent of angle A is the side opposite angle A divided by the side adjacent to angle A. And let's see, 28 is 2 times 2 times 7. None of those are factors of that. So we cannot simplify that. That's literally it. And then for the tangent of B, this is now adjacent to angle B, and the side that was adjacent to A, that's the side that is opposite angle B. So tangent opposite over adjacent, tangent of B is the opposite side over the adjacent side. And that fraction cannot be simplified. So the ratio of side lengths, that's a pretty easy question. You just figure out which side lengths to use, put them in a fraction, and that's literally it. All right, two more examples. Finding side length for one of them and finding an angle for another. So this is from 7.5 worksheet. This is number 7. First step is to assign the sides. Adjacent is the side that touches the acute angle along with the hypotenuse. Hypotenuse is opposite the right angle, and the side opposite is the side opposite the acute angle, 62 degrees. All right. So what I know, these two sides, what I'm looking for, the opposite side, opposite, adjacent. Tangent is the function I'm going to use. That's defined as opposite divided by adjacent. Substituting the numbers or variables from the problem, tangent of 62 degrees equals the opposite, that's my x, over adjacent, which is 25. Okay, this is a 2-step to get x by itself. Nope, sorry, lied. It's a 1-step. Just multiply both sides by 25, and then we get x by itself. There are calculator issue video if you don't get 47.0. I didn't have any units, so this is the x value for problem number 7. And last example from last week's practice, we're going to find Pn, we're going to find the measure of angle N, and we're going to find the measure of angle P. First, Pn, that's the Pythagorean Theorem. Pn is going to equal the square root of 18 squared plus 11 squared. Use my calculator for that. 18 squared plus 11 squared equals root 1 equals root 445. Can I simplify this at all? Let's divide a 5 out. 89 is a prime number, so nope, I can't simplify that. And here comes the real fun, the trig for an angle. Let's solve for angle N. Doesn't matter, we could just pick one. So this is the hypotenuse, always across from the right angle. Opposite angle N is 11. And adjacent to angle N is 18. Okay. I know opposite and adjacent. I'm using tangent a lot lately. That's just a coincidence. I didn't actually mean to write problems that use nothing but tangent, but I guess I did. Oh well. Anyways, so substituting info from the problem, tangent of angle N is the opposite side, 11 over the adjacent side, 18, and this is where inverse trig comes into play. We use inverse trig whenever we're solving for an angle. It's how you separate the n from tangent. You take the inverse trig of both sides. And then we use our calculator. Second tangent is inverse tangent, 11 divided by 18 in the super important parentheses. Okay, and that's 31.4 degrees. And the other angle has to be the complement of that, so you can just use the triangle sum theorem to get the missing angle. All right, so quick little example of a few of last week's practice problems. So check this video out if you have questions. Email me if you need more.